Reading this question, a magnetic field with a field strength of 1.2 Teslas, right, meaning this is the value of B, TB, through a conducting loop of the area 200 millimeters squared in such a way that the field lines make 55 with the plane. So the field lines make an angle of 55 with the plane. The plane is the surface of the loop. So this 55 is not the normal 55 because the weight normal is not there, or the weight axis is not there. So which means now, in this case, our theta is equals to 90 minus 55. Then they say calculate the magnetic flux linkage. So use the formula phi is equals to B A cos. Then B. So for me to know whether I should use this equation, this one, is because the equation has got nothing to do with EMF. We are not given EMF and we are not trying to find EMF. So it has got nothing to do with EMF. So we use the other one. Yeah. So now the magnetic flux is 1,2. Then the area. So they say the area is 200 millimeters squared. It was supposed to be meters squared. At this time around, it's millimeter. Now, how do I change millimeter into meters squared? So this is what you do. Say 200 divided by. I know that to move from millimeter to meters, you divide by what? By 1,000. But because this is meter squared, or this is millimeter squared, then you also square the 1,000. So when you convert so I know that from millimeters squared to meters divided by 1,000. Then you have to square the 1,000 because we are talking about the square, the millimeter square. So you get 0,0, you get 0,02. The cos of the angle and calculate the average EMF that will be induced across the coil if it is pulled out of the magnetic field. Right. So here for this formula we have changed in time the number of loops is 1. Then we don't have the change in magnetic flux. Change in magnetic flux is equals to final minus so the final flux, remember, it is pulled out of the magnetic flux. If it out of the magnetic field. So if the coil is moved is pulled out of magnetic field, then it means that magnetic flux is zero. The final magnetic flux is zero minus the initial magnetic flux. Webers. Now EMF is equals to -1 change in magnetic flux. Then comma 9 times 10 to the power -2. And the time is 0.1. Right, it's 97, 97, 97. Then there is the EMF. So we look at this one, a coil with 250 turns, and the area of that magnet is placed in a magnetic field with a strength of, what the hell?